This beautiful question from IE Rodo can be easily solved using the triangle law of vector addition. Let us start it. We have two particles A and B. Particles means they are treated as a point, their size is negligible, and they are moving with the constant velocities v1 and v2. At the initial moment, means t is equal to 0, you can consider their position vectors are r1 and r2 respectively, and the condition for the collision is being asked. Can you tell what should be the condition of collision of two particles? It's pretty simple thing. Very good. Two particles will collide if their position is same. Suppose here are two particles. If they want to collide, their position should be same. If they have the different positions, how they will collide? At the moment of collision, their position should be same. You get this? So let us draw it. Suppose here we consider the Cartesian coordinate system. This is x-axis, this is y-axis, and somewhere here we can show the z-axis like this. Here is the origin O. Okay. Now at some moment particle 1 is here at t is equal to 0. This is the initial position of particle 1. And the initial position of particle 1, if we want to show vectorially, we will show it as r1 vector. It's given to us in the question. The initial position was r1 vector and the r2 vector respectively. Okay. Now, suppose at some moment the particle 2 is here. This is the initial position of the particle 2. We call it r2 vector. They have constant velocities v1 vector and v2 vector. Let's say after time t, if we look at the first particle, it has traveled this much distance. We indicate that distance by v1t. And you can show a vector like this also. Now, this particle is moving with speed v2 and they have to collide. It means for sure the v2t should be like this only. Then only their position will become same. The particle 1 was initially here, then it has traveled the distance v1t in time t. The particle 2 was initially here, then it has traveled the distance v2t in time t. At time t, they collide here. So their position must be same. Now using the triangle law of vector addition, if we try to find the resultant of r1 vector and v1t vector, I hope you remember that resultant will be in this direction. And that resultant by the triangle law of vector addition should be written as what? Speak up. Perfect. It will be r1 vector plus v1t vector. Very good. Now, with respect to origin, the position of particle 2 at time t should also be here for the collision. So, if we use triangle law in this, then we should write r2 vector plus v2t vector. r2 vector plus v2t vector. This is the position with respect to the origin when the collision takes place. And this position can be written like as r1 vector plus v1t vector or r2 vector plus v2t vector using the triangle law of vector addition. Now, simplifying it further, we can write this as r1 vector minus r2 vector is equal to v2 minus v1t. I have shifted this term here, so it became negative. Now from here, if you want to determine the moment of the collision at time t, the collision took place. And that moment of time t now can be easily solved. So simplifying this t here, t will be equal to mod of r1 vector minus r2 vector divided by v2 vector minus v1 vector. Time is a scalar quantity and it is obtained by taking the magnitude of these two vectors. Vectors can never be divided, but their magnitudes can be easily divided. So we have obtained the moment of the collision here. Okay. Now, if you put the value of t again here, you will get your correct answer as this. I'm doing the calculation for you, just making some space for writing the things. Here we have r1 vector minus r2 vector is equal to v2 vector minus v1 vector, and the putting value of time t here, I'll be writing mod of r1 vector minus r2 vector upon mod of v2 vector minus v1 vector. Agree with this? Now bring this data here. So we are left with r1 vector minus r2 vector divided by mod of r1 vector minus r2 vector is equal to v2 vector minus v1 vector, and then this data is shown here, mod of v2 vector minus v1 vector, and that is the answer. Even you can learn it as a condition. If you want to write it in form of a mathematical condition, it should be written as r12 cap is equal to v21 cap. This is the condition of collision of two particles. Whenever this condition will get satisfied, the two particles will collide. Even we can obtain that condition here only. See, t is a scalar quantity. Once forget t. Now you look at these two vector quantities, this vector quantity and then this vector quantity. Here is equality. If there is equality, means the direction of this vector and direction of this vector must be same. Do you agree? T is a scalar. Direction of this vector and this vector should be same because here is equality. How we get the direction of a vector? Perfect. By finding its unit vector. Unit vector always gives the direction. How much is its unit vector? R1 vector minus R2 vector upon mod of R1 minus R2 vector. How much is its unit vector? V2 vector minus V1 vector divided by the mod of V2 vector minus V1 vector. So these are the unit vectors which are giving the direction, and these two directions must be equal at time t for collision to take place. I hope you got it. If you have any doubt, please fire up the chat box. I'll reply to your doubts. Stay awesome. See you again.